All right, so now in the back of your book, there's a table of integrals, and I've also posted it on Canvas so that um, you can take a look at that table and you can identify different forms of integrals and get the integral just by um, identifying the form and then plugging in, it'll tell you what the integral is for that form, and then it's just a matter of identifying the constants, the coefficients, and and plugging in numbers, right? Instead of having to go through the whole process of integrating. So table of integrals can be a handy tool, but it can be a little bit of a trick to figure out which form you're dealing with. So what I'm going to do is I'm going to have you take a look at, well, maybe I'll do the first one, and then I'm going to have you take a look at the table and see if you can identify what formula is to use and identify what the value of the coefficients are. So let's just look at this first one. We have the cosine of 8x times the cosine of 3x. Okay, now we have different coefficients on the arguments in cosine, right? So we can't use the normal methods methods we've just been learning. So let me bring over here the table of integrals into my screen so you can see it. And so let's look for that particular form. So if you come down here, you'll see that formula 11 down here has a cosine of ax times cosine of bx, which is essentially what we are looking for, right? Because we had cosine 8x and cosine 3x, right? So if let's see, can I move this around? I can then see that both at the same time. Oops, move it a little farther down. Okay, so you can see that this formula 11 is what we want. All right, so I'm going to do that. I'm going to make it 11. And in this case, we had two coefficients, right? And the a is 8 and the b is 3. Okay, so then it's just a matter of, now as soon as I activate one window, the other window pops behind. Oops, that's interesting. All right, so then it's just a matter of taking the result here and plugging in a and b. Okay. And then that's it. So makes it pretty easy. So let's do that. All right, now I don't know if I can get both of those things on the screen, but if you have the table of integrals in front of you, you can see where this is coming from. So we have 1 over, I believe it was b squared minus a squared, right? So we have 9, which is because b is 3, and then a is 8, so 64. So we have 1 over 9 minus 64 times, we're going to have 3 cosine of 8x sine of 3x minus 8 sine of 8x cosine of 3x plus c. Okay, and that's really all there is to it, is just identifying the formula you want to use, finding the coefficients that match up, and then plugging in those values, right? So here we had two coefficients a and b, which corresponded to this 8 and 3. And then we just plugged it into the formula. And then we're done. It's so easy. All right, so I want you to pause the video. I'm going to leave this all in one video, but pause the video and try to at least identify the formulas and the coefficients that need to be used. And then you can come back and we'll go through it together if you feel like you need a little extra help through this. So go ahead and do that now. All right, so let's take a look at this next one, part B. So again, it's just a matter of, let me bring back up the table. We had e to the 6x times sine of 7x. Okay, so let's try and find that form. So you can see it looks like 8 and 9 have e to the x times a trig function. All right, and it's formula number 8 that has the e to the ax sine of bx dx. So that looks like the right form that we need. And so then it's just a matter of identifying a and b. So a is the coefficient in the exponential part of the function, and then b is the coefficient on x inside the trig function. All right, so let me minimize that. And so we're going to use formula number 8. And in this case, a is 6 and b is 7, right? That's just, I'm just reading that off from here. And beyond that, it's just a matter of putting it into the formula. So so now I'm going to get, okay, I think it was, it's hard to, when I can't see them both at the same time. Maybe what I can do is I can have this, oops, no, I can't do that. Actually, I'm going to bring it over here so I can see it myself. You won't be able to see it because I can't get them both on the same screen. So, all right, so we had, it was 1 over a squared plus b squared. Wait, yeah, that's right. 1 over a squared plus b squared, right? So we have 36 plus 49. Now, I could simplify that. I'm not going to. And then we have e to the ax, so e to the 6x, all right? And then times 6 sine of 7x minus 7 cosine of, make sure I got that right, yep, of 7x. Oops. And then plus c. Okay, so just a matter of plugging in the coefficients. All right, let's look at the next one here. We have cosine to the 5th. Now you know how to solve this one now because it's an odd power of a trig function, and we could easily use substitution on this one. But we're going to use the table. All right. Now if I bring the table back over here so you can see it, it's not one of those. All right, we got to scroll down a little bit more. Okay, here, cosine to the n of x dx. Okay, and we have this formula. So the only variable really is n. And so let me move this. Oops, whoops, hang on a minute. I'll just minimize it. Okay. So we're going to use formula number 18. And in this case, n is 5. Okay. So now it's just a matter of plugging stuff into the formula. So I'm going to get 1/5 cosine to the 4th of x, because it says n minus 1, sine of x plus, so we have n minus 1, which is 4 over n, which is 5, integral of cosine cubed, n minus 2 of x dx. Okay, well that's a pain. we have another cosine to the n. All right, so well, fine. We're gonna apply number 18 again. All right, so I'm gonna take this 4/5, and then I'm going to apply number 18 again. So, but now in this case, n equals 3, right? So I'm going to get 1/3 cosine squared of x sine of x plus 2/3 integral of cosine, so it's n minus 2, so it's cosine of x dx. All right, I can solve that one. All right, so I'm going to have, let's just, I think we can just write the final answer now, because I got 1/5 cosine to the 4th of x sine of x plus, okay, I'm gonna distribute the 4/5, so I'm gonna get 4/15 cosine squared of x sine of x plus, again I'm gonna distributing the 4/15. All right, so I'm going to end up with 8/15, and then the integral of cosine is sine of x plus c. And there you go. We had to apply the formula from the table a couple of times, but we got our answer. All right, there's just one more. It's getting kind of a long video, but let's go ahead and do this one. If you looked ahead, now let me bring my oops, here, I'll bring that, okay. Bring the table back up. And so this one is 1 over cosine to the 4th. So it looks like number 21 fits the form, right? We have integral of 1 over cosine to the m of x dx. So in this case, m is 4. All right, so let's get that out of the way. And we're going to use formula number 21, and m is 4. Okay? All right, so we're just going to plug values into the formula. So we're going to get 1 over, no, it's too bad I can't have it up at the same time so you can see where I'm getting these numbers, but I think it says m minus 1. So this is 1/3 sine of x over cosine cubed of x plus 2/3 integral of 1 over cosine squared of x dx. Okay, so now we're left with another integral. Now, this one, we can actually rewrite this as 2/3 integral of secant squared of x dx. Okay, and if you remember, right, the integral of tangent was secant squared. Or sorry, the derivative of tangent, I said that wrong. The derivative of tangent is secant squared, so that means the integral of secant squared is tangent. All right, so we're going to get 1/3 sine of x over cosine cubed of x plus 2, whoops, I think I've been for this to be 2/3. 2/3 tangent of x plus c. Okay, so we get an answer for that without too much trouble using the table. All right, and that's all I'm going to cover today, and other than that is the discussion questions. Now, the discussion questions are all trig integrals, not using tables, and then your homework, the Wiley homework, will be all table integrals, and then the written homework is going to be the trig integrals. Okay, because the book for 7.3 is just about tables. Okay, the trig integrals is kind of a supplement that we're throwing in here. So, so go ahead and try the discussion questions, and we'll see you in class.